So what if an AI could do more than just learn a task? What if it could actually evolve the perfect body to do it? We're not just talking about software here. We're talking about a completely different way of thinking, where an AI designs its brain and its body together. And the craziest part? It's an idea taken straight from nature. Let's dive into this amazing world of embodied co-design.
All right, here's what we're going to cover. First, we'll look at the old way we used to build things and why it just doesn't work that well. Then, we'll get into nature's much smarter idea. We'll break down the three key ingredients, brain, body, and world, and look at four different recipes for putting them together. After that, you'll get to meet some of the wild creatures this process creates, and we'll wrap up by asking, what's next?
Okay, so first things first, let's really get a handle on the problem we're trying to solve here. It all comes down to this massive bottleneck in how we've always designed smart machines. I mean, it's a fair question, right? You see these incredible AI models that can write poetry or create amazing art. But then you see a video of a super expensive robot that can barely walk up a curb without falling over. What gives? Well, a huge part of the problem is how they're actually put together. So this is the old and, frankly, kind of broken way of doing things. It's a two-step process. First, a team of engineers designs and builds a body. It's totally fixed. Then, they hand it over to the programmers who have to somehow shove a smart brain into it. See the problem? That body might be totally wrong for the job, creating this huge performance bottleneck. The poor brain has to work overtime just to make up for a body it didn't choose. It's just not efficient. So, how do we fix this? Well, why not look to the greatest designer of all time for a little inspiration? I'm talking about millions and millions of years of biological evolution. And that brings us to the big idea, embodied co-design, or ECD for short. The magic word here is co-optimize. Instead of doing the body first and then the brain, this whole framework evolves them together at the exact same time. The goal is to make them a perfect team, totally in sync for whatever task they need to do. You know, the researchers behind this put it perfectly. This is exactly how animals got so good at what they do. Think about it. A cheetah's long legs and flexible spine are perfectly matched to its brain's lightning-fast hunting instincts. One wouldn't work without the other. ECD is all about trying to capture that same magic in our machines. So how does this actually work under the hood? It really just boils down to this incredible dance between three core ingredients. These are the three knobs that the co-design algorithms get to turn. You've got the brain, that's the controller, you've got the body, its physical shape or morphology, and then you've got the world, the environment that's constantly pushing it to get better. First up is the brain. Now, this isn't a squishy biological brain, of course. It's the software, the controller. It's often a neural network, like you see here, that takes in all the sensor data from the world and decides, okay, what do I do next? Second, you have the body itself, the morphology. We're talking about all the physical stuff, the limbs, the joints, what it's made of, where the sensors are. With ECD, all of this is on the table. Nothing is fixed. Everything can change and be optimized. And finally, and honestly, this might be the most important part, you have the world. The environment the agent has to operate in, whether it's a smooth, flat floor or some crazy bumpy terrain, that's the ultimate judge. The world provides the pressure that decides which brain and body teams are winners and which ones get left behind. Okay, so you've got your ingredients. How do you actually put them all together? Well, researchers have come up with four main strategies, or you could call them recipes, for making this evolutionary magic happen. The most popular approach is called bi-level co-design. The best way to think about it is like a design competition. You have one algorithm that's like an engineer proposing new body designs. Then a second algorithm acts like a test pilot, learning to control that new body as best it can. The best performing designs move on to the next round, and you just repeat that over and over. Next, there's single-level co-design. This one's different. Everything gets optimized all at once. Imagine you're designing a race car and training the driver at the very same time. Every tiny change you make to the car's wings immediately affects how the driver needs to take a corner. They improve together in lockstep. Then we get to generative co-design, and this is where it starts to feel like science fiction. This approach uses a big generative AI model, kind of like a master blueprint, to just dream up thousands of totally new and creative body shapes from scratch. It can explore ideas a human engineer would probably never even think of. And last but definitely not least is the most ambitious of them all, open-ended co-design. This is like creating a true digital ecosystem. It's a never-ending arms race. Not only do the agents evolve, but their world evolves right along with them. constantly throwing new challenges their way, forcing them to get more and more complex just to survive. Okay, enough theory. What does this stuff actually look like in practice? Let's get to the fun part and check out some of the absolutely wild creatures that have been born from these methods. This is what I love. The algorithm wasn't told, build me a four-legged walker or make something that crawls. Nope, it was just given a simple goal like get from point A to point B as fast as you can. And through evolution, it discovers that these different body plans are the best solutions. You get this incredible explosion of digital biodiversity. Oh, this slide is just fantastic. It tells the whole story. On the left, you have an agent that evolved on flat, dry land, and it came up with this furry, many-legged design. On the right, the exact same algorithm was dropped into a swampy, wetland environment, and it evolved into this slug-like thing. It's a perfect example of how the world shapes the body.
And this is super important. This isn't just a cool video game or a simulation. These very same principles are being used to design and 3D print actual physical robots. Robots like this one are being built to be tougher and more adaptable to the messy, unpredictable real world.
And here, you can see the process in action. It's just amazing. It starts with this really basic shape, and then through thousands and thousands of generations of trial and error, it slowly changes its form, adding a limb here, tweaking a joint there, until it finds a body that just works. It's digital evolution happening right in front of our eyes. So, all of this naturally leads to the big question. When you see how powerful this idea is, fusing the evolution of a body and a brain together, you can't help but wonder, where is this all going? Think about it. For billions of years, evolution was a slow, messy biological process. Now, we've handed the toolbox over to AI, letting it run its own evolution at lightning speed in a simulation. So if an AI can evolve the perfect body for any task in any world we can imagine, where does evolution itself go from here?